Oops, I need to be careful where my cursor is. That would be bad. Okay, so what we got here on the board? Yeah, 555. It's some sort of, I think this is a signal generator. It generates a certain signal. So, again, more kits, things to build. Okay. What else we got here? We got this one. And this was wrapped really, really well. It's like opening an egg. We open and we roll and we roll and we roll some more. And we have, oh yes, these guys are the same idea as the headers and stuff, but this is rounds, hold, road. They're really, really nice headers. I wanted some for a while, and now I got them. I'll add them to my collection of headers. Now, what do we got in here? Yes, all these are open because I have to register them on AliExpress that I actually received things. Okay, so this is, I think did I open one of these yet? Yeah, I did. Or did I? No. So I believe these are ESP Arduinos. Well, they're kind of like an Arduino, but they're built with, yeah, ESP 8266 on them instead. So I've heard a lot of things about the ESP having more room and faster and a bunch of other stuff, but all the pinouts are basically the same idea. Yeah, they've moved the little block that was here on a regular Arduino. Let's see. So if you look at this guy here, we've got this up here, right? They don't have that here. This one has lots of breakout. This is just happens to be a Key Studio Uno. So we'll find out about that later. Another little white one. I wanted some breadboarding wire. You know, stuff you just solder to breadboards. So I picked up a couple of bundles of pre-tinned, fairly stiff wiring. So and now, last time I misdid my feathers. So I had two feathers. So, well, I actually have more than two feathers. So I have the Huzo right here, Huza or whatever feather. Those are Itzies. And I have this feather. But of course I have these hats. And I'm just going to take them off here. So my problem was when I did all this, I didn't put a stackable header on any of these. So this one here, I got the bottom piece, but no stackable header on it. And the same with this one, the Huza. And this is the RP2040 feather right here. So all three of these, I kind of bungled them. In a sense, they should all had headers. Oh well. So I simply solved the problem. As you can guess, just buy more of them. Now, did I can't remember on this one. So I got the tricolor display. What am I missing? I think I'm missing the matrix display. So I'm missing the hat that's the matrix display. So I've got all the other ones. Yes, I got too much stuff on the table here. So these are the OLEDs. And I should have somewhere. Not in here. Did I put them somewhere else? What did I do with them? I should have had the third one, the matrix. The one with the LEDs in a grid. That's strange. What did I do with that one? Huh. This one is parts, programmers, projects, sockets. Huh. Well, I did something with it. I just don't know what I did with it. I really, really hate this. This thing just does not want to stay on this thing properly. It doesn't matter how hard I tighten it or anything like that. It doesn't want to stay. Now, what the heck did I do with that? Oh, did I stuff it in here? RGB matrix, bonnets, LCD. That's another LCD. Other LCDs. Well, that's really interesting. Maybe I moved it somewhere else. I don't know. I can't find it. Oh, wait, what's this? No, that's the Trinky key. That is that one. Yeah, no, I misplaced it. It doesn't got feet, so it can't go anywhere. Let's put those in there for the moment. So I have an Adafruit box here to solve this problem. So where is the opening on this box? Here. Also, it gives me an excuse to buy more batteries. You can only buy 3 batteries at a given time from Adafruit. Oops, it's still cut. There we go. And this is really, really well packed. There we go. Just throw this somewhere for the moment. We don't need it. So we have, you buy too much stuff when you have these all the time, because you buy over $100 and you get one of these. So I have my Playground, Circuit Playground Express. So I got a Bluetooth one. So someone else was asking about it. So here is stackable headers to go along with a Feather RP20. And this was a battery charger because I'm giving so many batteries. And here's another RP20 Feather. Here's 4 more. So I got 4 of those headers. And then in here, I have got 2 Feather M4 Expresses. So let's just open one of those up. This is, I think, the more standard Feather. Yeah, so this one here with a, the Atmel on it. So normally they ship with these. I'm not going to put these on. I'm going to put the stackable headers onto it. There's another one. And then I got another 2500 battery and a 500 battery and a 1200 battery. So 3 basic sizes here. So I've got a 100 type battery. I've got another 2500 battery. We don't need this. And then a gizmo to charge things. So what is the cable for? Well, that's great. Where did I drop it to? Oh, there we go. So we've got load, stat, battery, load. Well, the load is different between load and the battery. Thermal, program, power, DC in. Oh, okay, I see. Maybe that goes there. Into the DC in. Yes. Yeah, I could probably put that in here like this. I'll have to find out on the site what's that really intended for. And trash. So I've got those. Now, when I did the shop tool replacement thing, I'm just going to put all these over here. One thing, and I'm going to put these back in the little bin over here, along with this. I didn't show off. So on Amazon, let me just find Amazon for you. Mr. Amazon. Returns and orders. Secret sauce. So, and web searching. Let us change over to this one, properties. And we will do, there we go. So we'll turn off that one and turn on this one. So this is the station. And you can see right now, this is what the price was. Right? You know, it sucks. I just bought this and the coupon wasn't there. Now the coupon's there. Yeah, you can never win. You can never win. So you can see there's a better picture of the display. And those are the extra parts you get. That white thing in the bottom left corner is the spare heating element for the pencil. That's the air gun heating element. There's all the bits, the tweezers, and whatever that gizmo is. You know, if you know what that gizmo actually is, I don't know what it is. But I have to give this one a really high mark. Except for the Spanish people. I don't understand. Sacrifice build quality? No. What do they have to say? You get so what? The solder iron station's plastic. The lightweight of the iron and the tips, by the way. I don't know. Actually, I would have to get my thermistor off on my multimeter to check temperature. But so far, I set it on the thing for 365, I think, Celsius. And it had no problem melting the tinning bin where I tin the tips on. And as far as the lightness, my existing pencil is light also. So I don't see the purpose of having a heavy pencil. I mean, that just makes your hands sore. So, but I gave it a 5 out of 5 on this thing, right? And if quality is cut corners somewhere, I don't think they did. This thing is rock solid. I think there's a USB port on the back actually for some reason. Maybe that's how you program it. Like you can do get access to the microcontroller. It's usually in these things. But actually it works really, really well. So now one thing I want to do right now, since I got the time, let's turn on the pencil. And we'll turn on the soldering side. And unlike the SIG unit I had previously, this thing actually tells you on the display it's ramping the heat up. So what I'm going to do is going to borrow this. And we need one of these header packs. And I don't need to cut the bag on this. It's a zip. And let me change back to the base one. There we go. Sorry about that. Okay. So we put this on here. And we put this on here. And then what we want to do is go like this. No, wrong side. This way. And we put in that. We push down. So like this. And then I will get my little tool I've been using lately. And we'll unplug the stemma controller off that so we don't have it. Oops. I'm not catching quite in the gap there. There we go. So it's nice and down. And not a problem with the soldering pencil. Oh, I realized my copper cleaning thing is getting a little grungy, so I've ordered more pads for that. Thank you. Okay, so the object of the game on this one is just to carefully do the base. Well, I did have experience fixing something where the through hole was so narrow compared to what was being stuck in the through hole, which happened to be a three-legged LED. And if you're wondering, it's a two-color LED, not a three-color LED. But I was not impressed with it. I think the manufacturer could have done a little bit better. So there we go. Turn it around. Okay, itchy nose. Okay, here we go. The other side. It's kind of nice how the solder just nicely flows down into the hole. There we go. And the pencil is working perfectly, holding heat just nicely. So don't listen to some reviews. Okay, we release this. Like so. Now we can take the top off. There we go. Nice, perfectly stackable header, blah, 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 blah. Now, what I was working on I better tighten this down so it doesn't slide off. Put that back down here. So on this guy here, I'm just going to take these out. What I wasn't sure about on here was on these displays, do they use more than just the 3 pins? Like, I mean, there is the ICP, the power, and then the reset pin for resetting the display. That was my problem. So I'm going to try with this display first, I guess. Oh, I shouldn't have needed to take it off, but anyway. So we'll put it on. Oh, I know. Yeah, that one's got the code in it. But we'll redo the code. That's okay. So, stemma, solder, blah. Okay. So if we go over to code here and we plug this in, and we need USB-C for this one. Okay. And just to make sure that I am not going to damage anything, I'm just going to put this in a breadboard. Whoops. It is not going in this breadboard. Why? Let's just try again. This is an issue I have with cheap breadboards. Okay. There we go. That's better. So it's in the breadboard. We plug it in. It should show up in the File Explorer. I don't think you see the File Explorer, but I'm not worried about it. Just a sec. Console work. So our problems, I think, is there's no CircuitPython. Ooh. Okay, so we need to hit the reset button, which is buried in there. Boot select and reset. So I need a pointy device. And in here, give me a bit of cable, please. There is a reset. Well, that's interesting. We're not picking up anything. So let's put boot select on. Okay. Let's take this off. Okay, so we plug it in. Oh, that's not good. Why am I getting that? Let's plug the other one in just a sec. Yeah, that one's picking up. RT2040 Feather. So why is this one not picking up? Let's hold the boot select down while we plug it in. There we go. So RPT boot, and let's see, web searching RP desktop one. Let's see. So what we want here is work and Feather RP2040, and I happen to have the UF2 file here. Copy. And what we want down here is to mount that and paste the one file. Just like that. Okay. So we do a D message. Okay. So let's hit our little reset button here. There we go. And if we go back to File Manager again, CircuitPy. There we go. Okay. So it'll go back to our code. And I'm just going to move this off to this screen. So first thing we're going to do is, because it's a brand new one, we're going to open the folder. Just like so. So there's nothing in it. Now, it's going to set some stuff up. VS Code is going to end up with settings, JSON, stuff like that. One thing to watch out for when you go and save the workspace, I did this by accident. I had VS Code highlighted like this, and I went created a workspace and I put the damn file in here. No, I want the file to be here. So, file, I want to save workspace as, and I will call this Feather RP 2042. So I want my code workspace code direct file over here. So once you have that file, it's going to get populated with stuff, just like I've shown you before. So let's have a look at settings.json. So we see this, right? This stuff here is for MicroPython. Down here. Right there, you can see it. And so is this stuff over here. I actually have the MicroPython in my studio along with the CircuitPython. And then in this one here, we have all that. So I'm going to close this off for a sec. I'm going to save the workspace by closing it. I happen to have in my folder for Feather RP 2040. Do I have a backup? No. So first of all, I'm going to just dismount this because we want the files. Safely remove. Okay. And we're going to create a new folder in here, and we're just going to call it BU1. And over here, we're going to unplug this one. And we're going to plug this one in, the one I was working with. We're going to mount it. What we want in here is basically this, all this stuff actually we can take. Control C, and we go over here to our backup directory, and we paste it all in here. I want a copy of everything. So one suggestion, make sure you always safely remove. So safely remove. There we go. We go back to home here. We unplug this one. We plug the new one in. And we go down to CircuitPy. We mount it. So first thing, I want the contents of the lib directory because I was working on some stuff. So that stuff. And we'll go here into lib and we'll paste 4 items. There we go. I also want in the settings JSON, I think let's just open this up with Notepad QQ and just have a look at it. I think there are some paths and stuff in here I wanted. Yeah. So I want this file, copy, because I don't want to do the editing again. So, and I'll go back to U, and I will go into VS Code, and I will get rid of this one. And I'll paste one file. Okay, and I'll back up. And then in backup, I want this guy here, copy, open with Notepad QQ also. But in this case, what I want out of here is the content. I don't want to change the name of the other one. Control A, Control C, and I'll come back over here to CircuitPy, and I'll open this one up in NotePad-Q. And I will go Control A, delete, Control V, and I'll save it out. There we go. I don't need that, I don't need that, and I don't need that. Okay. So I just replaced the contents in this file. So now we go back to code, and we open the workspace up. CircuitPy, Feather RP22, open. So you can see down here, we are the RP Feather 2040. We've got all our code. Now what we want is we have this code.py with just hello world in it. But in our backup, I want the code this code. Copy. I'll go to CircuitPy and I will delete this one. Actually, I could just rename it. Code 1. Oops. Code 1 pi. Paste one file. There we go. Okay, we'll get rid of that. Okay, so we're missing Adafruit display and Adafruit SH1107. I thought I got those in the lib. There's 1107 MPY, and there's... Now, this could be simply a path issue in the JSON file. Port path, extra paths. And let's just check this one for extra paths. Yeah, so sometimes I get this issue with here, and all it really is just a path problem. So let's just see if we can fix it right away. It should be I think it's like a media little m circuit. Can't spell circuit. Circ UIT PY lib. And oh, we need a comma after there because it's JSON. And just for the heck of it, we will also put in here media. Oops, you're not finding it? Oh, that's all. Okay. Control V. That, comma, Control S. And we're down to 1 now. Display IO SH107. Okay. So maybe we need to rebuild. IntelliSense. No, not the platform. I want. Sorry. IntelliSense. It was working. Yeah, this pathing in Pylance is so freaking pithy. It's like it's not reading the MPY file. So what is the problem? Bundle the latest version. It's not a built-in. So why are you complaining? And it's so false. I mean, it's right there, right? SH1107. There is another way of doing this. Sometimes if I run into this, if I go back to work and I go to libraries, and since we're on 210806, if I go to the Pi version of the things, lib, and in here will be also an 1107. So Adafruit, display IO. We need the other one here. This one, Adafruit display IO. There, 1107 Pi. Copy. And we go and say Control T. I need another directory. And we go back to CircuitPy. And we go into lib. And we paste this one file. See? Import problem. Why does the Pi file work, but the MPY file doesn't work? I get this all the time. It's like endless, but this is a way you can get around it, but it costs space. So this is a bigger file than this guy here. But anyway, so what we want is we want that in there, but we should play it safe and do it without the power. So close workspace. Go here, safely remove. There we go. Unplug, put this on. Plug it back in. And open this thing up again. So file. So all I did was put the top on the thing. So open the file. No, open the workspace. No, not yet. Sorry, mount CircuitPy. There we go. So open the workspace. Ta-da! Okay, so change over to base just so you can see this. There we go. Now it's working. So the display is working. Little flicker in there though. It's definitely a flicker. I wonder why. I wonder if there's a refresh in here. Really? So you can change the border to 1? What happens if you do that? Oh yeah, that's thinner. Okay, splash, color show splash, display bitmap, sprites, draw a smaller inner rectangle on a black. Yeah, we got all that. Draw. Label some text. The answer is 42. Control S. There you go. The answer is 42. But there you go. There's the OLED screen. See, now I'm pretty sure that, and I don't know why they're not marked on here. So they only mark the SDA, SCL, ABC, reset 3-volt and ground pins. But there must be more going on in here because I can't tell on this. It's hard to tell on the traces on here. I can see the ABC lines. But the other ones, I don't see any traces coming off in this. Well, no, I see a trace coming off this one here, third one in. Between the 3 volts and the ground, there seems to be some stuff. So I don't understand why, if you have it side by side like that, and you run the appropriate I2C communication and stuff, why it doesn't work. That is a bit mysterious to me. So, but it works. Now that's that one. And I wish I knew where I did with my other one. I was going to mess with the little matrix one. You know, and I thought I had it, but it's not in this bin. So what the heck did I do with it? I must have tossed it in a bin just to get it out of the way. So it's not in the tool bin. What if it's in this bin? Oh, yeah, here it is. Doink and doink. So we have, I think these are NeoPixel, and these are LED. And as you can see, I made these legs really crooked on these. That's better. And let's deal with this one. That's better. Did I straighten these ones out too? Oh no, these began straight. So we have the little LED one. So let's try some new code. Okay. I'll close the workspace. And go over here and safely remove. Okay. And take off this. Okay, so we have that one. So let's us do the NeoPixel one. There we go. And we plug it back in. Mount the CircuitPy directory. We will right away rename this code. Rename, and we will call it code 2. And we will go over to here, and we will go here. Whoops, William, don't do that. And we're going to go look for, so this is called NeoPixel Featherwing. So NeoPixel Featherwing. There we go. So here's the thing. So we need some code. And we need a library too, probably. So let's go assemble pinouts. Yeah, see, they only mark 3 pins needed on this thing. And then the control pin, of course. Usage. Okay. Download. Oh, we don't need the schematic. Usage. We'll do this one. Okay, the Uber guide. Okay. Form factors, basic connections, powering the software. We need Python and CircuitPython. There we go. So we've got this thing on. Okay, CircuitPython installation, NeoPixel libraries. What do we need? Latest version, yeah, blah, blah, blah. Okay, so we need NeoPixel MPY and Adafruit bus device. So if we go back to desktop 1 and we move my mug away. So we have, yes, William, that's really work. And we have libraries, and we have MPY, and we have lib, and we need, as I said, NeoPixel. NeoPixel MPY, copy. Then go to CircuitPy and we go into lib. And we paste this one. Okay. And then it says we need Adafruit bus device. Okay, I think I already had that one in here. Yeah, Adafruit bus device. Okay, got those. Now we need some code. Full example code, copy code. So if we come back to here and we back up one and we say create new full text file, code.py, and we go here to our Visual Studio. Which, why am I bouncing on the keyboard? There we go. File, open workspace, circuit, RP2, open. Okay, Control V, Control S. Okay. So NEOpixel. See, again, MPYs, right? Okay, we're going to fix that right now. Work. Same stupid thing. The MPY doesn't want to work, so we'll flip over to the Pi files in lib. So we need the NEOpixel, blah, blah, blah. There it is, NEOpixel, blah, copy. And we will go to CircuitPy to the lib, paste the one file. There we go. Notice the error just went away, just like that. Okay. Can we open the repo here? Yeah, we probably can. There we go. Control C, Control D. Okay, not working. Number of NEOpixels. I don't think there's 10 on here. 1, 2, 3, 4, 5, 6, 7, 8 by 16, 32 pixels. So first of all, we have 32. Okay. Now we need a where's that definition for the pin? The pixel pin. Okay, so they said there was a feather had an open pin that we have to change. Okay, so where is that code here? Feather wiring, board D5. So let's change this to D5. Oops. D5. Well, I don't think that worked, Henry. That is not the right one. No. So it is, let's see, long pins on the bottom, short pins on the top. B for battery. So which one are you running on? So if we're not on D5, what are we on? Well, let's see, have a look on here. Battery enable USB SIN. They said on the picture for the pinouts, one of them was jumper. There's the default control pin. So let's have a look here. Basic connections. No. We need the other. Let's just duplicate this page, please. And on this page, let's go backwards. Not the Uber guide. Not this one. Not this one. This one. Pinouts. Okay, here we go. Two pins right here. NeoPixel feather use. There's only one data pin. You also have 3 pins that can be used for power. So which is my data pin? We need a data pin. Yeah. Right there. So on the short side, we've got it on from this side over here. Here, let me just show what I'm looking at. So we need to find this pin right there. This guy. So pin 6 is for feather 32, 328, M4, MRC, MOs, M16 on Esp. So we have a feather. Good Lord, we have a feather that's not that. Okay, so we have on the short side going in from there, we have 4. So 1, 2, 3, 6. So it is 6. Okay, so D6 maybe. 6, Control S. There we go. Ta-da. We got it. Red, green, blue, rainbow colors. Extremely bright to the camera. I wonder if I can tone down the camera a little bit. Top cam. Properties. Can I tone you down a little bit? Saturation. Exposure. Well, that makes the desktop darker. Gain. That makes the whole scene brighter. Brightness. Contrast. Nah. That doesn't do anything. Saturation. Doesn't do much. Not much I can do. White balance temperature. What about that one? White balance temperature. Let's turn off that and see what happens. Nope, that just makes the scene look really weird. Sharpness, backlight composition. Well, you get the idea. I mean, you can see it. It's just really, really, really bright. And I don't even have anything I could stick over it. Like, I mean, nope. I'm just washing out the poor camera. And even this. Yeah, see. Trust me, though, it is doing what it's doing. So that's that one. So we know it's pin 6. And this is the NeoPixel file. So we have another feather here, a DotStar feather. So let's close this off. File. And we're going to go back to code here. Sorry. And file. Close off the workspace. And go to this and do a safety remove. Okay. So we take off the NeoPixel, which is extremely bright. And we put on, ta-da, DotStars. Okay, so we plug in. And of course, we need to mount. And this code right here, we're going to rename it to code 3. Okay, so we'll go back to here to our web searching here. Now let's go find the DotStar feather. And you can go over here. DotStar feather. Right here. Okay, so pinouts. Same thing, except on this one, better. What's data pins? 2 pins, C and D. So we have on the short side pin 4 and 6. So 4 and 6. Okay. Usage. And we're going to go over to this one, 4 and 6. Okay, so comparison, form factors, we don't need that. Software. Python. There we go. So there's all the wiring. And we need DotStar and bus device. Now, since we've had trouble with our MPY files, let's go find DotStar in here. Adafruit DotStar. Adafruit DotStar Pi. Copy. There's a lot of room on the RP2040s. They actually put quite a big thing on there. So go into lib, paste one file. There we go. Okay. Now I'm just going to move my pick mug over here to get it out of the way. We'll switch back to the code window. And we will open the workspace again. Circuit Pi, open workspace, open. Okay. So we need a code file. So I need a new file. Code.py. Okay. So we need a sample file. Download, demo. Full example code. Copy. Control V. Okay. Control S. So, what do we say? So we need this one. So we're not using this one. We are using this one. But we are not D6 and D5. I'm pretty sure we are split between the two data pins. So we go back here. Not the NEOpixel. DotStar and pinouts here again. So C and D. So we had 6 already. It looks like 4, not 5. Let's try 4 on here. Nope. Let's try 4 here and 6 here. Still no go. Okay. Using a DotStar digital LED strip with 30 LEDs. No, we have 1, 2, 3, 4, 5. Whoops, I can't even count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12. Another 12 is 24. Another pair is 48. 58, 60, 72. Not 30. So I'll change this to 72. So either I got this flipped wrong. Well, according to this, it's C and D. Data and clock. So which one is which? If C is data and D is clock. Data in, clock in. Okay, so clock in is 4. Okay, so let's see. That's our data. Clock first, then data. So clock is 4, data is 6. That's correct. So why aren't you running? Yeah, you have no trouble with that. Control C, Control D. 72 LEDs. Okay, so let's go back to, so we got the pinning, I think, right. We need the coding. Okay, so this one's not working quite right. What am I? And I've got a red light on the board. There's a green light also. So what are we missing? So okay, what is this complaining about? New code up. Oh brother, no, I think I'll skip that for the moment. Should have worked. Don't know why it doesn't work. Import add through DotStar. Yeah. And we're not using a strip. We're using a grid. On board, DotStar for boards include Gemini, Trinket, and Itsy Bitsy. Using a DotStar digital LED strip. But we're not using a strip. We're using a grid. Usage. Okay, well. Okay, let's copy this code here. Okay. Control A. Back. Control V. Control S. And in here, oh, we got some Adafruit dots. Oh boy. Oh, this is whoops. This is C code. Not good. Now let me just check here. In the Explorer, and I'm just gonna go over here to desktop. I also have unpacked all the possible examples. So we're gonna go and work libraries examples. Let us find the what is it called? DotStar, yeah. So DotStar, let's see if there's one in the DotStars here. Circuit. DH display IO. DotStar simple test. DotStar image paint. Copy. No, open. Open with Notepad. Yeah, Control A, Control C. Let's see what this one does. I think it might be the exact same code, but I'm just going to try it out. Control V. No, it's a little different. We don't have this DotStar. We have this one. And we have clock on 4 and data on 6. It's still not doing anything. Are we sure about that? Yeah, that's the DotStar wing. So why is my code not running? Pinouts. There are 4 power related pins. Yeah, battery, USB, and da da da. Ground pin, yeah, data pins. So 1, 2, 3, 4, 5, 6. Yeah, show you what I'm working at. It is 4 and 6, C and D, clock and data. And I have board D4 and board D6. I need to change that to 72. And we're still not getting anything. Yeah, so we've got, starting here, we've got base, we've got enable, and we got USB, and this, so 1, 2, 3. Are they considering this 1 and 3, not 4 and 6? Let's try that. Maybe they're considering that differently. Where's my cursor? There it is. Let's try 1 and 3. Nope. Okay. Well, that's funky. So it doesn't work. Data and clock pins, yeah. Data over here, clock pin over here. And according to this, we are, oops, I keep doing this code. We are passing first the clock, then the data, then the pixel count, brightness, auto rate is true, pixel order, BGR, baud rate 4000. So we should be right here. What I don't understand is that considered data 1, or is it considered data 4? Is 1 considered the battery? I mean, what do they offer for? So they offer for pins off the board. I2C. That's it. That's not right. D2. D4. D3, D5. It is skipping one. And D4, D6. Nope, none of these work. And the funky thing is they don't come up that correctly. I wonder. Oh, I know what I can do. What's that command? Circuit Python. Show pins. There was a technique you can do to figure. Yeah, here it is. So we go like this. We say import board, and then we go dir board. So there we are. Okay, so we've got A1, A2. Usage. Oops. So I need to look at the picture for, and I have that. Here, let me just go back to desktop one. So, there it is. If I go back to here and I have a look, I believe I downloaded this. Right. So we got 13, 12, 11. Damn things backwards. Okay. That explains a lot. This is 13. This is 11. Still doesn't work. Okay. So bat lib VSB. So we've got GP13 and GP11. Not D. Right. Oh, I think let's try that GP because nope, still not right. I think I'm on the right track. 13, 12, 11. Oh, so 13 is going to be the clock and 11 is going to be the data line. Just slide this over here so I can look at it. So 13, according to Adafruit, and let's move this up. Clock is 13, data is 11 on the board. Well, on this Feather RP board. We haven't tried this yet with the other Feather. This is only the Feather RP 2040 that we've been doing on. So far, we had 2 out of 3 here. So should be working. 13 is clock and 11 is data. So why aren't you actually working? Physical pin number 44 and 42. Okay, RPI GPIO number is the brown. So we've got 13, GP11, 13, and GP11. Yeah, that's right. That can't be something as that. No, it's bigger as 10. And I don't think this. Nope. Pretty sure this should be 13, 11, but why is it not working? Hmm. 13 is also tied to the LED. Purple NEOpixel. UART function, I2C function, SPI function. No, I'm not using that. Using a DotStar digital LED strip with 30 LEDs considers pins. Using the digital DotStar hardware SPI. Well, SPI is... Nope, we're not on that. Gemma, Trinket, Mississippi Dots on cyber board, APA 102 SCK, and AP 102 Mosey. Just a sec. I need to find out board dot. Yeah, I mean, technically the board's not giving me pins. But here, it's listing it as D13 and D11. But the diagram's listing it as not that. Nope. Oh, we have problems too. What's the problem? Expect the member name dot py. Oh yeah, of course. Duh. So we've got the A0, A1, A2, A3. We got the D0. We got D0, D1, D10, 11, 12, 13, 24, 25, D4, 5, 6, and 9. 5, 6, 9, 10, 11, 12, 13 according to the diagram. And there's 24 and 25. Where's D9? Oh, there it is, D9. Okay. Well, RTS1, RX0. I'm not sure. The demo does not work on the RP2040, and I'm not ready yet with another feather. So I do have this is an RP20 feather, of course, and what we have here is let's see, other RP20 feather headers. Right, the pinky bags. So this guy here, and I don't have this set up yet. So this one here, this Atmel. So I need to prep one of those this weekend. Or maybe tomorrow. So we are stuck. Something is not going right here. I think I have the board right, but apparently not. So close the workspace. And we will close this. Safely remove. We'll have to look at this either tomorrow or the next day. Work tomorrow, so I can't stay up too late. So, yes, we should have gone at 13 and 11 right there. So I'm not sure why I'm not having any luck with it. Yeah, they would have us change this. So that middle pin, that 12, is not really even on the matrix. Is not connected. I mean, clock in pin here technically is SCL0. And if we take SDA0, technically, that is an I2C thing. Oh, and look at that! Right off the end here, they have here on the web, they have D in and clock in, data in, clock in. So uh, we are not doing NeoPixel Uber Guide. Interesting. So on this picture here, they're showing 1, 2, 3 in USB red. Then they're showing yellow and blue. D5, D6. Okay. Pi connections. And I copied all the code for the DotStar. This is the same code, basically, just a little more extended. Well, I think that'll have to be it because I have work tomorrow and can't do anything more about this at the moment. But pencil works. Most of this is working. We'll get some other things to work on. I have to figure out that LCD display with the more pin rows, and I have that solar panel stuff. We'll see what we can do. And I will turn my pencil off. Now, they warned me to wait 30 seconds or so before turning the whole thing off. So I'll just let it cool down a little bit. But the pencil is working just perfectly fine. I'll get the thermostat out. I got the gizmo that you put on one of my multimeters. It gives you a temperature probe. We'll find out what temperature the tip is. We'll see how hot it is. But this should be it. And as I said, if you have comments or you like or dislike or the usual YouTube stuff, you know where the buttons are below the thing. I don't need a tail end piece on the picture to tell you all that. I hope by now that everyone's figured that out. So, good night.